All right, so we are going to talk about Docker. Um, Docker is this super cool technology, frankly, as we put here, game changing. Um, and it is basically a virtual machine, and it gets used for a lot of different stuff. What it has become really useful for is deploying projects to the cloud and like consistently creating like the environment as in the operating system and how the database is set up and all the things that were pain points in InstallFest. We can write code to automatically create our environment the exact same way we want it every time, whether it's for our own local development environment or for deploying onto AWS. And as you all have learned from getting your hands dirty with all of the InstallFest and managing your local dev machines in AWS, that's huge. So let's very briefly talk about virtual machines, and then that can lead us into Docker. And there's no wrong answer to this one because we haven't talked about it a ton. Someone just tell me like what is a virtual machine, or like what's your best guess as to what it is? And those of you on Windows have been using WSL2, which is a virtual machine. George, yes, sir.
Kind of like a computer inside of a computer, but it doesn't know it's inside another computer. It's like it thinks it's its own machine.
Yeah, you hit the nail on the head. A virtual machine is a program that completely simulates a computer, as in hardware, as in an actual physical computer, down to the hardware level. WSL2 is an example of this. If any of you have played like Nintendo games or PlayStation games or anything like that on your computer, other game emulators are examples of this. Those are you on Mac, if you've dealt with, well, Boot Camp is a little different. Linux has Wine. Um, and in fact, like there's, I don't remember the details, but like the actual like chips on our computers have something built in there to help enable virtual machines. So the point is that when a program is running inside a virtual machine, um, it can't tell the difference between the virtual machine and an actual physical computer. There are kind of like the movie Inception, right? Can you tell the difference between like a dream and reality? You run into like weird edge cases here and there with this stuff. It's not perfect, but it's actually extremely good. And one use case for virtual machines is like running code securely. So if you have code you don't trust, you run it inside a virtual machine, and it makes sure that the code only works inside that environment because it cannot access anything outside the virtual machine, like the real operating system or the real computer. So it's very inception-y. And I'm curious if folks have any questions kind of around virtual machines just while we're talking about them a bit. Cool. So I don't know the details, but I'm pretty darn sure that, when we talk about the cloud, we're talking about virtual machines. Like, in fact, as we'll see, we're even more so, we're talking about like Docker and Linux containers, which we'll get to in just a minute. But for the purposes of argument, you can all imagine that those EC2 servers we created on AWS for deployment or from that deployment lesson, it's not an actual physical server somewhere. It is a virtual machine It's a virtual server that Amazon has spun up somewhere in a database. And you can imagine if you were running a data center, this is great because you can like have a whole bunch of physical servers, and you could maybe have multiple virtual machines for the clients of your data center for hosting websites or web apps or whatever. And you could have a bunch on one server, on a physical server. And even better, you can save the state of this virtual machine. And if, you know, the physical server, because it's doing so much work, because it's running 24/7, you know, if it, I was going to say something not quite work appropriate, but if it dies, you know, then you have, you've saved an image of that virtual machine, like maybe as a regular backup, and you can just have your client's application run on some different server. So those are the pluses. The downsides is, as you can imagine, if I'm full on simulating, say, well, Windows or Mac would be, I think, particularly tough, like to do a VM for. But if I'm fully simulating a Linux virtual machine, that could be pretty resource intensive. And that's been a problem with these things. And there's a lot of just edge cases and challenges. So Docker came along, and where is the one I want? There we go. And Docker uses a technology called Linux containers. So we'll talk a couple minutes about how I get Docker on Mac or Windows when neither of those are Linux, and hint, it will involve a virtual machine. But for now, let's just think about Docker as something specific to Linux, and it uses a Linux specific technology called Linux containers, and it's a lightweight virtual machine. And let me just go ahead and make this image bigger and do a little annotating to point out some key differences here. So a virtual machine has this full emulation layer. Each virtual machine gets its own whole operating system happening inside each instance of the virtual machine that we're running. And thus it becomes like more heavyweight. I actually don't know a ton about how Linux containers are implemented under the hood, but thinking of it as a lightweight virtual machine is very appropriate. And as soon as I find where my mouse pointer went, there we go, we can talk about the differences. All of the different containers share an operating system. They share system resources, like say maybe access to the screen and the keyboard and stuff like that. So the downside is it's not as secure. If I ran some malicious code inside a Linux container, it sort of has access to some shared memory, and it's and the shared operating system. It's not running inside a whole nother operating system. But the plus is, if I trust my code, this is incredibly lightweight. So this thing called a Linux container is a lightweight virtual machine that shares some things. It shares like the operating system, and it shares a bit of memory here and there. And Docker is essentially a bunch of software written on top of Linux containers. And let's go ahead and get rid of these. So they share the host operating system kernel, while each virtual machine has a full-fledged guest operating system, which means they can boot up faster. They're more portable, at least from Linux to Linux system. They don't provide as much isolation and security, right? A VM, you have whatever's running inside that virtual machine totally inside a completely separate operating system. that thinks it's running on a totally different physical computer. We don't get that same level of isolation. But that means that Docker containers are way more scalable because they take up way less resources. So you could imagine, again, think about deploying to the cloud. Think about like we're a dev team of 20 and our web app is big and we need like we need like 3 or 4 Django REST APIs and a load balancer that balances traffic between them and an instance of our database, and we have like a caching layer or something. If I can use a technology like Docker to containerize all that stuff so that I don't have to like be manually hacking how each individual Linux box is working, and I can have all the code for each Docker container checked into version control, that's kind of amazing. So I don't want to, I want to talk a little bit more about why Docker matters and why we use it, but I do want to make sure I get to the good hands-on stuff in just a minute. So before moving on, do folks have any questions sort of around like the basic high-level overview of what this technology is? Nathan, yes, sir.
Yeah, I'm just kind of wrapping my head around it. So like
Yeah, it's a little
with like
inception-y.
with like a virtual machine, I mean that's kind of more of like an operating system and like a desktop, how like normal people interact with a computer. Would you kind of use a virtual machine? Like if you're developing like an application, would you kind of use that to test it on different operating systems? Like would you spin up like a virtual machine and like load your app on there to kind of see how it works on different, I guess, specifications?
Got it. Great question. You could, and in fact, you might. Um, but let's talk through. Let's draw a couple diagrams. So let's talk about it. This term normal computer is a little like undefined, but you know, the everyday user, what Mac students have been doing, those of you on Windows have been using a virtual machine since day one of class with WSL2, as you all know. So we're running the computer and we're running the actual hardware of the computer. And somewhere like it might even be, yeah, we'll have the hardware there, and let's say then we have the operating system. And the operating system has stuff like driver code to talk to screen, keyboard, Bluetooth, Wi-Fi to hardware, right? That's a big part of what operating system code is like the code that talks to, I mean, and even more than this, to, let's say, you know, the I want to say hard drive, but these days it's usually a solid state drive where everything is stored, right? So there's like this low level driver code that every operating system has that actually talks to the physical hardware of our computer. And we never really interact with that directly. You know, and in fact, let's make the operating system way, 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 way bigger. And like somewhere in here is, you know, maybe, you know, the Chrome web browser, and somewhere else in here is maybe my Python app. But there's a bunch of layers that the operating system has. If you all remember kind of day one of class talking about the Linux kernel, like my Python app, like doesn't talk to this driver code directly. It talks to the operating system, and then the operating system talks to the driver code most of the time. And so like this is essentially when like everyday users are using a computer, or again, except for those of you with WSL2, what we've been doing the whole class, right? We haven't been using a virtual machine or anything like that at all. The inception-y bit is and let me go ahead and make room for this. A virtual machine is literally running a program that thinks it's a computer inside the computer, and everything else inside there thinks it's in a computer. And Nathan, as you pointed out, we could possibly, one possible use case for this could be testing on different operating systems. The truth is virtual machines can be a little wonky, so like most companies that are serious about testing are just going to run their code on the actual operating system, on the actual hardware in question. For browsers, it's a little bit of a different story. That's where for web apps it becomes more practical. And you might use virtual machines for testing and stuff, but also bear in mind, like a virtual machine does suck up a lot of resources. Computers have gotten really powerful now, but like those of you using WSL2 can definitely speak to the pain points and things like, you know, what does it mean to run Chrome inside a virtual machine? Because if it's going to talk to the internet at some point, it needs to talk to the actual driver code for, say, you know, the network card or whatever on the real computer. So if for certain things, depending on what you want your virtual machine to do, you still have to have like interconnection points, and that can get tricky. So those are some of the limitations around that. Nathan, I know I diverged a little bit from your question, so I just want to check in to see if that was helpful and see what else is on people's minds.
Yeah, no, that was helpful. Trying to I was thinking about that too, like using because I did a lot of video editing and stuff, and a lot of it talks about like using a virtual machine to like do large render, like render large files that would just take forever on like your local machine, and so that's kind of where that's where my mind was going.
Say that last part again.
Like I know there's like a workflow for like motion graphics and like video editing where you would basically use like a virtual machine to render like your large files so you didn't use all of your computing power on that and it would take significantly less time. And that's kind of where my mind was going, thinking about like
Oh,
virtual machines, I guess.
interesting. Yeah, I would have to see what that is. That sounds cool though. Um, I'm honest. Yeah, I'm honestly not sure what they have set up there. Um, and I mean, like the, you know, like I don't know if like Mac users still need a virtual machine if you want to like run Windows to like parallel boot to play games, but like stuff like that for a long time was like a common use case. Um, Adrian, you had a good question in the chat. A virtual machine is just software that uses the host's physical components to run. I think I misspoke in the chat because I misunderstood your question. Yeah, I would say that's correct. I mean, so technically speaking, any software that we're writing is using the host OS, and the host OS provides access to the physical machine. Like every time I use Chrome or write a Python program, it's talking to the operating system, and the operating system has the driver code to talk to, you know, like the solid state drive to save stuff and render stuff on the screen. Um, the virtual machine, it simulates all of that. So again, like if I'm running my Python program inside a VM, my Python program has no clue it's inside a VM. From the Python program's perspective, it's running on an actual physical computer because like all of this stuff is simulated. And let's add maybe like the final layer of hardware, and maybe that will help too with this. We can draw a couple boxes, you know, and here is, you know, let's say keyboard, and CPU, and the SSD that actually, when you save a file to your hard drive, it goes on the solid state drive. And we'll throw one more in, and that will be the monitor. Or actually, we'll save the monitor. And so I guess if I'm going to build this out a bit more, here, I'll make it in red. The virtual machine is simulating all of these things too. It simulates a whole CPU chipset. It simulates a keyboard. It simulates the solid state drive. It simulates some sort of screen to put stuff to. So, I mean, eventually, because the virtual machine software is running on my actual physical computer, we are using those resources, but my Python program running in the VM never gets direct access to any of that. It interacts with all the simulated stuff and thinks that it's running on a real machine. And as you can imagine, this is quite resource intensive. Like it takes a lot of processing power because we're like simulating a whole nother computer. Yeah, it simulates all the computers. David, you were saying it simulates all the hardware that you're using. A use case that's pretty common is managed attribution for doing research so that other people can't see you using a computer in the US. And I can see that as well.
Yeah, when you think about like organizations like Bellingcat or other people who are doing work like that, virtual machines are pretty common.
I actually don't know what Bellingcat is.
It's like a collective of open source research people. Like they look into like conflict zones, other like politically contentious situations across the world, and use online research to kind of shed light on what the situations actually are.
Got it. Thank you. Yeah, so yeah, that's a great example of a use of a virtual machine. And as you pointed out, it gives some security because any code running inside the VM only knows about the VM. And so it can't interact with my actual computer to find out some sort of identifying information, whether it's like a MAC address or something else. And so if you're in a part of the world where things like that are a concern in terms of like surveillance and stuff, I could see well, I don't know the details. Like I could definitely see a virtual machine being used there. What else is on people's minds with virtual machines? Cool. So let me go back and find the other diagram that I love. This one. So we dug a bit into virtual machines. A Linux container and Docker is a Linux container. Don't give us quite as much separation. We're not completely simulating a whole nother operating system and hardware. Right? That's the big difference. And so a Linux container only gives you Linux. Like with a virtual machine, I can run Windows on a Mac because I can simulate a whole nother machine and run a whole nother operating system inside my operating system. It's super inception-y. Docker is like partial inception-y. It's only Linux. I can run another Linux inside my Linux, and I don't quite get the same complete level of separation, but it's way less resource intensive and way more lighter weight. So this is kind of the fun and the funny part of Docker is if we go to the Docker website. And so Docker's a for-profit company. Linux containers were around for a while, but in the let's see, when did it happen? In 2013, a company was created to support the Docker project, which had previously been open source. because these Linux containers became really useful for like DevOps and deploying software to the cloud. Because like all the web app software on servers everywhere and most things running on virtual machines in the cloud run on Linux. So this is actually quite useful. So the question is, I'm on a Mac. It's Linux based, but it's not actually Linux. How do I run Docker? So the answer here is I download a program called Docker Desktop. There are other ways, but this is the easiest to do it. And if you're on Windows, you could download this too. And Docker Desktop runs a virtual machine. So when I am running Docker on my Mac, it looks something like this. And we'll make this blue. And then inside here, we'll have this be orange. And here I might have like, I will talk about like Docker containers and what these are in just a minute. So it is kind of funny because Docker is like this lightweight thing that means, oh, we don't have to use a virtual machine. And then we kind of sort of do on Mac and Windows to run it. I'm not 100%, but I'm like 80% sure that this is what's going on here. But we get some pretty incredible things. So what you all are going to want to do as you're getting into Docker is I do recommend just going to Docker. I do recommend just signing up for an account. And I'll talk in a moment about the value of that as well. I would just use your Google or your GitHub. And you're going to want to download Docker Desktop. So the cool thing about Docker is like once I have like created like a Docker container, it's called an image, I can share that with other people. The same way that we can use GitHub to share code. And Docker has something called the Docker Hub. The same way that you can go to NPM for JavaScript packages or PyPy for Linux packages, like we can actually go to Docker Hub for Docker images. And we're going to dig into what a Docker image is and what a Docker container is. But if I go in here and like we poke around, and it takes a little bit of poking if we want to define the actual code. But and we're going to learn in a minute like what a Dockerfile and all this stuff is. Like, because this is a lot of stuff. But what this is a bunch of code that will create Linux with Postgres set up exactly how we want it, exactly the same way every time. And it creates what's called an image, and that's like very much like a virtual machine image where I can grab and I can pull down this Docker image that has Linux with Postgres set up and configured a certain way right off the bat. And it's not just Postgres. Nginx. You want to use Nginx for local dev. Like that was a pain point for us in the deployment lesson. We can use a Docker container that's running a little Linux container with Nginx running inside probably Ubuntu or something, ready to go. You want Ubuntu Linux. Here it is, ready to go and configured. Or let's say we want like so Django, I guess they've deprecated. But we could create one with Django. And here's a Docker container that has Linux set up with Python and everything already installed. So a really common use case for this is, say, like you join a new company as a junior dev, there's maybe like a Docker image that has like maybe it's Python and JavaScript and whatever else you need to write and develop code, all set up and ready to go, and you pull it down and you run it and you connect to it. And instead of doing your development in your main system, maybe you're working most of the time in the Docker container that has your environment ready to go. So I think this is probably a good time to switch gears and actually start running and showing some of this stuff so we can see it in action. Does that sound good to folks? Okay, awesome. So we've kind of talked through a lot of what's going on here. Again, the two big use cases here are like developer tooling and deploying stuff to the cloud, especially for DevOps, but really for anything. When you all are working with Docker, you're going to want to install Docker Desktop and create a Docker Hub account. So what we're going to do now is I'm going to walk through sort of, I guess, the Docker version of Hello World, which is we're going to grab a Docker image, which is, remember, I've got Docker Desktop. I've already installed Docker Desktop, and let's, I've got it hiding somewhere around here. There it is. The Docker image is a whale. Whales and shipping containers. I like the Docker images. And I use the desktop a little, not a lot, but this is, I do need to have this running. If this wasn't running, all the Docker stuff I'm about to do on the command line wouldn't work. And in fact, I can show that as well. So if I'm not going to quit this because it takes a minute or so to start up. But anywhere on the command line, once I've installed Docker Desktop, I also get some Docker command line commands. And if I type Docker, and then we get all this output. If I type Docker PS, it tells me there's no containers currently running. And we're going to talk about what all this means in a minute. And here you can see different things just visually about what's going on with Docker. So I'm going to pull down an existing Docker image for Linux and run it interactively so we can maybe use its command line inside the image. And we're just going to see like starting and stopping images and how that works. And while we do that, I'll talk a little bit more about sort of Docker architecture and key terms. And then we'll get into actually creating a Docker file for Postgres. And that's going to sort of be like step one of what we'll build over the next day or two in terms of how to, it's called like Dockerize, like our full stack application. So there is a solid explanation and breakdown here of everything that we've been talking about with Docker in the curriculum doc for today. I do think it's worth reading. I will share the resources that we have in our DevOps curriculum as well. They mostly say the same thing. There's a little bit of differences. So this is the main, before I start writing code, this is the main stuff that I want to point out just to talk through terminology just a bit. So the fact that I can type Docker on the command line and that it does something, that's part of the tools that get installed to use Docker. It follows a client-server architecture, just like we've talked about with web apps, where like Django is the server and the browser is the client. A client is just the program that requests stuff from a server, and a server is just the program that gives stuff to a client. So I have a service, which is just the name for a program running in the background of my operating system called the Docker daemon. And daemon is just Linux OS speak for a program running in the background. And this manages all of the different Docker containers and stuff that we're going to create, and talking to like how containers talk to each other and allocating memory space for them and stuff like that. And when I start up Docker Desktop, this is running. The Docker client is the command line program that I was using just now to do stuff, to interact with Docker. And we also saw the Docker Desktop GUI, which is another client. And then Docker images, which is like a whole Linux container set up and ready to run, are stored on the Docker Hub, which is some server in the cloud, just the same way that like npm stores JavaScript packages and stuff like that. We could have other registries as well, but that's sort of like the main one, and we'll use this for most of the stuff we'll pull down. So an image is like the actual executable like software that we run that actually runs this Linux container inside our OS that has everything we need. And a Docker container is just a term for like a running instance of an image. So I can start and stop an image. I can start an image, change some stuff to the operating system, stop it, save it, share it with you guys. And that's what we're going to learn to do in a little bit. There's some very useful cheat sheets that we have here, by the way, in the curriculum. So I highly recommend looking at those as you get into this. Let's just go ahead and I'm going to do a little building of stuff. And this is the one I want. So I'll just kind of have this up here, but I'll just sort of like walk through this. And let me just kind of give us a bit more room so we can look at stuff. So this piece, I think, is more specific to Linux. The easiest way to say it, the easiest way to see if Docker is running or not is you just type Docker. And if you get all this stuff printed out, I know that my Docker command line client is up and running. And I can see a list of the Docker help commands, running a container, stuff with executing containers, listing all the different containers. We'll talk about building images in a minute. Pull and push is what we're about to use. And run. Right? I'm actually about to run Ubuntu. And there's two flags here with this run command that are particularly important. -I is for interactive and -T is for terminal. So the same way we SSH'd into like an EC2 instance on AWS and we could be on the command line there, we are telling Docker, I want to be able to interact with this Ubuntu Docker image I'm actually about to run through the terminal. So what's going to happen when I run this is I can't remember if I have the Ubuntu Docker image already on my computer. I might from having done stuff with Docker previously. If not, the Docker client running on my computer is actually going to talk to Docker Hub and pull it down the same way like, you know, you run npm install and it installs a JavaScript package from the npm site. And in fact, we see it doing that right now. And note that this command prompt is not the one I had just a moment ago. If I type, who am I? It's not Adam C. If I type pwd, it's root. I am, in fact, this command line is running inside a Docker container that has Ubuntu, a whole version of the Ubuntu operating system running on my Mac. So I have a whole separate like Linux OS here with two commands. Really one, just this one command right here. And if I type exit, I'm back into my computer. I'm my own user. If I type Docker PS, we see that there's no current Docker processes running. Let's actually run Docker help less again, because I need to remind myself of some of these commands. So let's run Docker images to see the listed images, and I think we should see Ubuntu there. And then I'll kind of just do this again real quick. And check it out. So here's the Ubuntu image that I just pulled down. It actually doesn't take up that much memory, which is kind of incredible. And that's the beauty of Docker. And let's say, just for the sake of argument, let me create a text file and let's edit it. Vim is not installed by default in Ubuntu, so I'm going to use an even older command line based text editor called VI. And not even that is installed, so that's fine. I've created the file, that's enough. What I want to demonstrate is I exit and I re-enter. And actually, you know what? It looks like it's not saved. I apologize. I think there's an extra step that I missed there along the way, maybe of associating a volume or some other command so that that file would have been saved. Because I thought that we would have gotten that saved, but I think that that's actually not the case. And if I open up another terminal tab real quick right now, I'm not in the Docker image. And if I type Docker PS, I see that I have this container running. Right? So a container holds an image. A container runs like we start it or stop it. The image is like a snapshot of the operating system and all the stuff. And a container has an ID. We see here the image name that it's using is Ubuntu. This was the command used to run the container, how long it's been up for, and Docker assigns a name for stuff. And there are no ports assigned to this right now. So it can't connect like to the internet or anything like that. So there's a bunch of stuff we could do inside the Docker container. We could install dependencies. Here are just some commands. We've seen Docker PS a bit. I don't think I have anything running right now, but PS-A, in fact, shows like all of the containers that we have, whether they're running or not. So in fact, the issue here, and the issue I was running into, is I created 4 separate Docker containers with that command, and I was going into a different one every time, right? And I was like, well, hey, where's my foo.txt that I made? Well, the issue is I wasn't going into the same Docker container. That command that I was running was creating a new one every time. So let's just use, I'm just going to use the ID, I think. And let's run, instead of creating a new one, let's run a container we've already created. And I do apologize. It looks like I am not doing that one right. So let me make sure I don't have my commands confused, because I think I probably just got a little rusty on this and forgot how to run a specific container. And indeed, I believe here I was forgetting the name flag so that we can tell Docker what container to run. And the BusyBox stuff, we don't have to worry about so much. BusyBox is like a super tiny version of Linux. It's here for teaching purposes. The key thing here is this name flag. And I think it will take the Docker ID as well. If it doesn't, I'll just replace the ID with the container name. Let's see here. Oh, I see. All right. In fact, I am just going to cut straight to the chase and use ChatGPT to help me out here. I apologize, folks. So this was my bad. I need to use Docker start instead of Docker run. and this is a bit confusing. Run creates a new container off of an image. Let's try Docker start. And so now it's running, and I can start it, and I can stop it, and it needs a minute to stop. So we're giving it a minute to stop. There we go. And I believe if I start it and tell Docker I want to interact with it through the terminal, through the command line, there we go. Just start -I. And so now I'm inside this container. And let's see if it's still running. It's not. Let's try starting it again. And now my file's there. So I got a little lost in the mix there, but we got to dig in and see a bit more about Docker. We saw start, we saw stop. I saw that I don't necessarily have to go inside a Docker container when I run it. For instance, like what we're going to see in a minute is we're going to set up a Dockerfile for Postgres, and we're not going to directly go into that Docker container. We're going to use pSQL or other things to interact with Postgres. So you could imagine, say, with Django, like if maybe you want to give the front end people on your team like Django and Postgres set up and ready to go in one Docker container, you can give that to them, and then all they need to do is run it, and then they rarely would actually need to like connect in to the Docker container on the command line in it. So most of this stuff we've kind of like walked through. We've seen Docker start, we've seen Docker stop. This is a good command as well. Like let's say I do start my container, and I can use the ID or the container name. And then I decide, hey, I actually do want to interact with this. I can use the attach command to connect to the interactive shell running inside that Linux OS in my Docker container. And its name, it's a little hard to see here, is Charming Gangly, which was auto-generated by Docker. So I could do Docker attach, let's see here, Charming Gangly. And I think the last thing I do want to demonstrate is if I want to create a Docker container and I want to give it a name, I first need to give what's called the base image, the image that's running. So I'm going to use Ubuntu because we've been doing it, but we'll call this like my image. And let's see if I had this backwards. There we go. And if I go here on my computer, right, I'm not inside a Docker container at the moment, and I do Docker PS, I see that there is indeed a Docker container running. The base image is Ubuntu, and the name is my image. So the command is the name I want to give it first, and then the base image second. And then I can start it. And let's just start it interactively. Or, well, actually, let's just start it with the name. And I can stop it with the name as well. So let me just pause here and check in and see what questions folks have, because I know I've been digging into a lot of stuff. Brian, yes, sir.
So it seems like you were able to copy an existing image for Ubuntu and then start and stop one or more containers that are running that image. And once you're running a container with that image, then you can modify it by like, adding, deleting files or whatever. If there is a image that you want to modify, like Ubuntu, and then put like a bunch of stuff on it, like, I don't know, is that something that you would do to create like your own custom image that you could then replicate?
Yeah, exactly. And you raise several good points here, Brian. So as you pointed out, I created a bunch of different Docker containers, sort of by accident, but it was actually useful for what we wanted to demonstrate. They're all based off of the same image, Ubuntu. But each of these are a completely separate Linux Ubuntu operating system. And I can create files in one of the images, and they persist in the image when I start and stop it, because Docker has saved memory, like on our real physical computer, to save stuff for that image. And that's why once I finally did get stuff sorted out, we went back in and foo.txt was still there, but it's not going to be there in one of these other ones where I didn't create it. So I can start any one of these containers and modify it and stop it and start it again, and the change is there, but it's not on the others. And in fact, I might want to delete some of these. And then the question you raised, Brian, about, hey, this is awesome, I want to run with this, I want to change and add stuff and share it with other people, is where we're about to go next with Docker files. Yeah. What other questions do folks have? What else is on people's minds? Okay, cool. So here's the golden rule of Docker, and this is coming from experience, and we'll use Hopeful Merkle as an example. Let me start and connect to this Docker container. There's nothing inside here. Let's create a file named foo.txt. Let's create a file named bar.txt. Let me go ahead and start the image that I created. And note there's nothing inside here right now. I don't think I created any of these files. And let's start up again. Hopeful Merkle. So let's pretend we're working together, and this isn't like just foo and bar. This is maybe like installing Python and pip and Postgres and setting up the Postgres user, and maybe even we're going to set up Nginx. And it's a whole lot of work. And now I've done it. And the beauty of Docker Hub is what I can do is sorry, we have this command here. And in fact, let me go ahead and just do Docker help less. I can build an image from a Docker file. I can upload an image. So I can take all that work I've done, and I think it's the push command that will actually push up the container as an image. I'm not certain. But point being, now that I have this Hopeful Merkle Docker container that has all of the work in it, I can share it with the rest of my team by putting it up on Docker Hub, and you all can pull it down, a lot like GitHub. However, you don't want to do it this way. We're going to see Docker files in just a moment and how to do it. The problem is this becomes a black box. With the Docker file, we're going to actually write code with all the commands, with all the stuff that we want. And that code gets checked into GitHub. And then we can all read the Docker file and see exactly what has happened. I have worked at jobs where we have had Docker containers where 3 people who had left the company before I joined had done tons of work in there that was not documented, and we did not know what it was. And we had like production systems and like websites running off of these, and we were afraid to touch it because we had no idea what the heck is going on in there. You all saw, that there's a whole lot of configuration stuff that happens. So the golden rule is you never, like any change that you care about needs to go into a Docker file. You never ever just like go into like a running container and directly change stuff there. If it's stuff that you want to like keep and share with the rest of the team. Let me go ahead and just show Docker files so we can see what that is, so I can make that concrete, because that will help a lot. And let's in fact go up to the lesson, and I'm just going to kind of run through this. So here's a preview of a Docker file. So there is a Postgres latest image. I could in fact do Docker run Postgres latest. And there we go. I am talking to the Docker Hub server. It is pulling down some Docker image that probably has Ubuntu Linux and Postgres already installed. And we're seeing some errors here because since it's Postgres, I have to set up something. I can't just run it. But I wanted to demonstrate, and in fact, I see this isn't running. But I wanted to demonstrate that, in fact, there is a Docker image of Postgres running on some Linux, probably Ubuntu Linux, already set up. And so every Docker file starts with this command called from, and this is called the base image. So, and you always just have the file named Dockerfile. So all of the Docker containers that I was creating now from Ubuntu, it would probably, this is really all that the Docker file looks like, because somewhere up on the Docker Hub is already a Docker image named Ubuntu. And from here, I could add stuff like apt get install Postgres, for example, right? And I could actually create a Docker Postgres image from this. And in fact, that's how this Postgres image is created. And we'll kind of see a bit more of this later. But we're going to dive in and actually build a Docker file. Though I do actually want to, I think it would be really nice to see a Docker Postgres image. So let's actually Docker Postgres GitHub. I do want to see if we can find the Docker Postgres file. So it gets more complicated. Yeah, maybe like Docker Ubuntu Postgres example. Here we go. So somewhere on Docker Hub, Canonical, a big open source company, they have a Docker image where they've installed Postgres on Ubuntu. And if you give me a moment to find where their GitHub lives for this, because I would like us to like actually see this Docker image. Then we can see what this looks like before we dive in. And I know it's hiding somewhere here. I honestly, for the life of me, cannot figure out where they put it on GitHub. So let's try Canonical Postgres Ubuntu Docker GitHub. And let's see. Yeah, this isn't quite what I wanted. This is some other stuff. Let's see if I can find it here real quick. And if I can't, then I'm gonna give up. Yeah, I apologize, folks. I'll try and find that later. Canonical, what I sort of skimmed over, but Canonical, I believe, are the folks that actually create Ubuntu. Yeah, I apologize. I'm getting a little into the weeds here and a little off topic. So let's go back to building the Postgres. Sorry about that. I think you all will kind of be able to see it as we build out this Dockerfile. Docker files are kind of awesome and inception-y. So every Docker file starts with from, and this is the base image. This is some other Docker image that we're going to use to create our Docker image from. So I had wanted to find, and I'll share it later, the Docker file for this to show you all, because that's the cool part. You can kind of like, if you look at this, this will use something else as its base image and so on and so forth. So there could be like 3 or 4 or 5 stacked on top of each other. But let's go ahead and set this up. So if we looked at the docs on Docker Hub for the Docker Postgres image, and in fact, we can go ahead and do that. They'll actually give us instructions on how to use this in here. There's a quick reference, there's a description, how to use this image. And they give us the run command and they tell us, hey, you do have to set these environment variables. The Docker command is a bit more complex, the Docker compose stuff. But this is sort of the guide that we need, because this stuff that we're adding here are environment variables, just like we've been doing in a .env file or on the shell. Like, remember, I could do Postgres user equals foo, and if I do echo Postgres user, that variable now exists in this running shell environment. And remember, Docker images are all Linux based. So we're creating some terminal commands essentially that we're running here. So we're creating some shell environment variables that this Docker file is going to create and run this image in. And Postgres user is going to be equal to my user, and Postgres password is just going to be my password. If I don't expose a port, it's going to be very difficult, if not impossible, for any other program to interact with my Docker container. So Postgres runs on 5432, port 5432. We'll see in a minute that Postgres inside our Docker container is going to run on 5432, but we're going to connect 5432 to a different port so it doesn't conflict. So we're going to create a default database. And I am just going to copy and paste these arguments just so that we have something. I am actually not 100% if we need these, but it certainly isn't going to hurt to have them. We may or may not get those as defaults from Postgres. This is things like character encoding and stuff like that. The interesting thing is the command that runs when we start the container. So this is how you can run the same commands that you would run on the command line here in a Docker file. So this, again, this sort of walks through what we're doing here. And this is worth reading through, but we've sort of been talking through it. And And some of these, I guess, are actually necessary for super user rights. So this is the fun part. We're going to create a new Docker image from this Dockerfile. And the command we use is build. That creates an image. And remember, once we have an image, we can make a bunch of different containers from it. And this says, hey, Docker, create an image, give the image this name, tag it with this name, and the Docker file you're looking for is in the current directory. Otherwise, I might have to do something like this or give a relative path to wherever the Docker file is. Right? And in fact, let me make sure, indeed, there is my Docker file. So let's create this image. So this is kind of cool because we just used a Docker image to create another Docker image. And now what we're going to do is this command right here. And kind of the key bit here is this part just kind of hiding there where -p stands for port. And we're doing a little port mapping. Because I have Postgres running on my actual Mac right now. You know, if I just do pSQL, that connects me to the same, you know, Postgres that we've been using the whole class with all the different databases and stuff. And that Postgres is running on port 5432 because that's sort of Postgres's default port. So on my actual machine, port 5432 is created. So what I'm going to do is I'm going to tell Docker, hey, when you run this image, when you create a container to run this image, map the image's port 5432 to the actual port on my computer, 5433. So my computer is going to have port 5433 to talk to Docker on. And then the rest of this is a bit more straightforward. We've seen the Docker run command. -d will run this container in detached mode. It's going to run in the background, which is what I want. I don't want, you know, this to lose this terminal. I prefer to have it going in the background. We have the port mapping that we talked about. So my Docker container is going to be accessible on localhost port 5433. We're going to give the Docker container a name, like we were saying, and an image. And this RM flag is just for cleanup purposes and for sort of demonstration purposes. You may not want to use it when you're actually doing work because this will delete the container when it stops running. There's probably not any harm for now in that, especially because you want to use the Docker file for all the important stuff. So let me go ahead and copy and paste this command and let's run it and see what happens. So I would have thought maybe because it's running in the background. Let's see if my container is running at all. Or if I did something wrong here. So we built the Docker image, my Postgres container. I honestly don't know why it says created 2 months ago because we just built it a moment ago. And so that exists. And so Docker run and all of that stuff should work fine. The name stuff should work too. Let's just simplify this command a bit. Though actually, let's see if we can, maybe this is running in the background. I will try to use pSQL to connect. If it doesn't, then I have a couple steps here for debugging that will take. I don't suspect it is running because I do think we should see it even if it's running in the background with Docker PS. But we'll try connecting anyway using pSQL. to connect to port 5433. And we're going to have to make some changes here, I think, to connect with the right user and password. And in fact, I'm going to use ChatGPT to help remind me how to do that. And it's -u for the username. So let's do pSQL -u, username my user. The DB name is MyDB, so -d MyDB. It's going to prompt me for the password when I hit connect. And so now we'll do the host name, which should be, I believe, localhost 5433. And let me sort of do a little cleanup here on the screens and get back to, yeah, we'll do host and port right here. So host is localhost, port is 5433. So let's see what happens. Port 5433 connection failed. Is the server running? So my guess is the server is not running. So let's back up here and just break this Docker run command down a bit and see if we can't get this working. So let's start with Docker run, and we'll do the port mapping 5433 to 5432. And let me go ahead and clear. And this name stuff I do want to keep, but I'm not going to worry about like running it in the background or anything like that. I just want to see if I can get it to run. And in fact, I want it in the foreground to figure out what my problem was. So I'm going to run and create a new container. The container's name is going to be my PostgreSDB. And excuse me, the image is my PostgreSDB and the container name is my Postgres container. And I suspect that, first of all, it would help if I had the -p flag in front right here. So this is progress. We at least got Postgres running. It is asking for a password.
You have a typo in line 4.
Oh, that would do it, wouldn't it? Yep. I'm sorry about that, guys. Let's see if that does it. Because this is in the Docker file and it builds the image with these environment variables, I think what I'm going to do is delete and rebuild the image just to be safe. So we'll do like, let me actually use ChatGPT to help me here. RMI, yeah, okay. RMI, my Postgres container. Unable, blah, 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 container is using its referenced image. So this does point out, like, I did create some containers with this, but they don't seem to be happy. So I'm just gonna delete as much as I can. And maybe this one as well. So I got rid of the Docker containers, even though they didn't work, they had been created off of that image. And let's see now if we can delete that image without complaint. Indeed, it does delete it. Docker did not let me delete the image that existing containers depended on. And now let's try running that build command again. It shouldn't take too long. Docker does a little bit of caching. Now let's try that run command and see how we do. There we go. Thank you so much for pointing out that typo. I would not have thought about that. So we fixed our issue, we cleaned stuff up, we rebuilt the image. Indeed, Postgres is running, but this isn't very useful, right? Because I mean, I actually can connect to Postgres from another terminal here now. I believe now if I do oh, well, I don't have the command in here, but if I do the pSQL login command that we put together just a moment ago, I think it was something like pSQL u my user d my db h localhost p 5433, and now it's prompting me for a password. So now I am actually in the Postgres running inside the Docker container. And I can't even remember my SQL off the top of my head it probably doesn't let me create a table without any sort of columns or anything like that. I'm sure my syntax is wrong, but we can see here the database name is MyDB. We can see there's not really any other databases here inside this Postgres. So we are indeed in the Postgres running in the Docker container that's running here. And in fact, if I go ahead, and in fact, if we look at this log that's coming, because I didn't run this in the background, I didn't use that -d that was in the command here for detached mode, because I wanted to have it in the foreground because I had the error before and I wanted to debug. And so we're in fact getting like the Postgres log, and right here we see error, syntax error at blah, 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 statement, create table foo. So sometimes it can be useful to have a Docker container running in the foreground so you can get these logs and like error messages and stuff, and just have another tab where you're interacting with it however you want to. And if I go ahead and kill this, it's shut down. And if I try to do anything here, it's going to give me some sort of complaint. And indeed, that's because we've stopped the Postgres server. So that was really so there's a couple modifications you may want to make to this command. The -d, if you want to run it in the background, you would keep that. When we run pSQL, you may need to add the username and the database instead of this bit. And again, that's where I think ChatGPT can help. And then we have all of these other tools that we've been learning about with Docker, and in terms of like starting and stopping the containers. So in fact, let's go ahead and run this again, but let's run it in detached mode. Oh, right, I already created the container. I always get a little confused about this. If we do docker ps-a, here is the container I already created. Its name is my Postgres container. I can stop and start it now. And in fact, it would help if I got the actual name right. I could also just use the container ID, which can be easier sometimes, to be honest. And so now I have Postgres running again. I could connect with it to pSQL and so on. Any changes, any data I put in there is going to be saved, and then I can start and stop my Docker container with Postgres. And I can have that be completely self-contained. So there were a couple hiccups along the way, but we got to see how to build this out with Postgres. And so then here is kind of like the amazing part. Let's see here. The name of our image is my Postgres container. So I think we got the naming a little backwards in the curriculum right here with the run command. I think these two should have been swapped, but that's fine. In fact, I'm sure there's a way to rename this. But I'm not going to worry about that right now. But let me just make a temp directory real quick. So here's the cool thing about Docker. No, and that's some autocomplete that I don't want happening. And I think these might need to be in a command block. In fact, they might need to look something like that. Just as an example, now that I have created this image, I can use it in another Docker file and build on top of it. And that's where Docker starts to get kind of cool and inception-y. So I know there were a couple bumps along the way. And I kind of went through a lot of stuff. So I just want to check in and see what questions folks have and what's on people's minds around sort of like Docker images and containers and what we were just walking through. And the context here is this is sort of just the introduction, and what we're going to see over the next couple days is creating a Docker container for, say, like Django, and also for Nginx, and using a tool called Docker Compose, so we can have multiple of these containers connected together for your whole system. So we haven't gotten there yet. Today is more of an introduction to the technology and showing how to set it up with Postgres. What you could do, and I'll share this. So first of all, we have a couple cheat sheets that I think will be really helpful with Docker. As you saw, like it's, even I'm getting confused with containers and images. That I think that's an easy one to get confused on. And here we go. If you are looking for a good way to get familiar with Docker, actually the Docker Nginx container is a really good starting point. And so this is from the DevOps curriculum. And there is a little web page. And all it is some JavaScript and an index.html. So you don't have to worry about Flask or React or anything like that. And it's like a little numbers game. And using the Nginx Docker container to spin up an Nginx server to host this could be good practice, because you'll have to do some port mapping, which is what we saw where I mapped from port 5433 to 5432. And you'll have to do a little reading in the Docker docs on Nginx, because they've actually done a beautiful job of making Nginx easy to use. And they, in fact, give some examples here, but it touches on some things we haven't gotten into yet with Docker volumes, where the question is, hey, if a Docker container needs to access code that's not inside it, how do I do that? Or how do I, edit code in VS Code that's in a Docker container. Well, let me tell Docker to share a volume and map, say, a file on my computer to or a directory on my computer to a directory inside the Docker container. And so what we're seeing right here with this command is we're mapping a directory where, say, index.html could live to where Nginx running inside the official Nginx Docker container is expecting to find some sort of HTML file to serve. They also kind of walk through how you could do this with a Dockerfile with some more advanced commands of copying, but I would recommend just starting with this. Because it actually, this gives you everything you need. You don't actually need to set anything else up, I believe, just to host and run that little app. But you know, to make it work, you will have to probably do a little reading and thinking through to get more familiar with the commands. So if you want to, I would suggest that, as I think that's a really good exercise. And I'll go ahead and share that. I lost it. I apologize. I'm jumping around through a lot of commands. Here we go. Serving the runaway game. I'll share this with folks. There's some background reading here that could be good. The stretch assignment you all don't have to worry about. And what I did want to point out was, yeah, the Docker file for Postgres is a bit complicated. We can see here it's using a version of Linux called Alpine, but we're seeing lots of conditional logic in here. It does things like setting up directories, creating directories for stuff. There's an awful lot happening inside the official Docker Postgres container. The official Docker Nginx container, or Nginx's official Docker container, might be a bit simpler. If we take a quick look at that, we can see what their Docker file looks like, if it's any better. It does start to get like more complex, but as you can see, you can get awfully far with the simple stuff. Let's see here. I feel like somewhere in here should be a base. There we go. Yeah, it gets, as you can see, it gets even more complex to set up and configure this. I was hoping for like a nice, clean example that we could see, but it may not exist in like these real world Docker files for real world things, because so much configuration and edge case stuff needs to happen. But the essence of it is pretty simple. Like if I told ChatGPT, make a Docker file with Ubuntu as the base image that installs Python 3 and npm and JS and Nginx and Postgres. Like this is something I think much more understandable for us as a starting point. Like say we wanted one Docker container with everything we needed for our full stack app for simplicity. We're going to use Ubuntu. apt-get is Ubuntu's package manager, and ChatGPT has added all this stuff, frankly, and all this extra stuff. But we can see here, essentially, we're installing Python 3. Again, there's stuff, they got fancy with it, but we're installing Node.js. Here, they're actually installing Nginx. Here, they're actually installing Postgres, and here we're exposing some ports. And here's the command so that every time this Docker container starts, Nginx starts, Postgres starts, and there's a terminal session starting. So I realized that this was a bit of a brain dump, but I wanted to at least show a Docker container with a bit more going on, like a Docker file, and you could see how you could put your whole full stack app in there if you wanted. Now, best practice is to have separate containers for each service and have them connected with Docker Compose. But on a practical level, this is not the worst way to get started. Because this actually gives you everything you need to deploy onto AWS and EC2. You know, if you had everything you needed in one Docker file for your group project, then on AWS, you can run, you know, like Docker pull to get your image, and then you can start it right up and skip all of that, most of that stuff we were going through manually in that deployment lesson. You still have to do the same stuff here, but you do it once and it's in code and it's reproducible and way easier to develop and debug and test. What we'll see tomorrow and onwards is using Docker Compose to have separate Docker files for these pieces and kind of connect them together. But just to show you, you can, you know, stick it all in one. So this is probably a good pausing point. And I just want to see what's on people's minds. And if you all have any questions in general about Docker or related to maybe your projects. I think Nathan, you said you guys and Tom were maybe starting to use some of this stuff. And just to check in, are folks sort of like, all right, I think I need some time just to absorb this, and this was a lot of information, or where are we at? Yeah, I apologize. I know I had a couple typos along the way that added some extra steps. So there's a lot of stuff here, but just to recap, let's sort of do a little bit of a summary. Or actually, even better, let's use TL draw for a summary. So let's do a little bit of a summary. Someone maybe help remind me, like, what is a Docker image?
A virtual machine.
Yeah, essentially, yeah. A Docker image is, think of it of a snapshot of a whole Linux OS with whatever stuff has been put in it. Right? It's not an actual virtual machine, but like you can have all of Ubuntu as a Docker image, or Ubuntu plus Postgres configured with a database already, or whatever as an image. Docker images, how do we create Docker images? So we can create a Docker image from a Docker file. We run Docker build, and just maybe this isn't the full command, but just to point it out, something like that, right? We can use a Docker file to create an image. A Docker file always has a base image. It is built off of some other Docker image. And where else can we get Docker images other than creating our own? from this Docker Hub site, right? That has a repository of images. For instance, here is the official Python Docker image. And let's see if we can see their Docker file and if it's less terrible. Okay, so this is actually much better. A Docker file built off of some other Docker image for a version of Linux named Alpine. Linux Alpine version 3.18. We're setting some shell environment variables. We're running a bunch of command line scripts to do whatever. And we're installing Python. But where we end up with that is here is a Docker image for Python already set up on Linux. And if we scroll down somewhere on here, if I want to say, do something else so that I have Linux and Python already installed in my Docker file, I can just start with from Python and it's the version after the colon. And this is my base image that has like Python already installed on Linux. And maybe we're going to install Django on top of this. So there is a big repository of existing Docker images that we can use to build on top of, and we kind of just stack one on top of the other. What is a Docker container? And this one is a little trickier, and I'll be honest, I might reach to ChatGPT to help with the description. What's the difference between like a container and an image? Brian, yes, sir.
Is it kind of like an instance of an image? I mean, if an image is kind of like a class definition, you're instantiating it, and you can do that multiple times.
Yeah, I think that's a very good analogy. We can have multiple containers from the same image, just like we could have multiple instances of a car class in Python, right? And each container could have separate stuff in it. And in fact, let's use ChatGPT here to help. Because I always get a little fuzzy on describing this accurately. So I am all about using all the tools that I have at my disposal. The image is, right, a packaged application. It's the whole OS and whatever else we put in it, everything that we need. It's created from a Docker file that includes all of this powerful configuration stuff. Basically, think about everything you did in InstallFest on day one, and now imagine putting all of that into one Docker file. And then you could use that and have a Docker container and do the whole class inside of that. And in fact, we've debated if we should or should not do that. And that's honestly how devs will often use this. Once an image is created, we can't change it. You can store images in a registry. Brian, like you were saying, a container is a running instance of an image. Docker creates a little sort of runtime environment based on the image. Containers are isolated from each other. Containers can be started, stopped, and deleted. And containers can interact with the actual host operating system. And Adrian, to answer your question in chat, so images define containers and explain what containers will do. Yes, I think that is a reasonable analogy. So to run with this, let's say I have, let's use maybe the circle. and we'll make it red. And let's say that this is like a Docker image, and maybe like it is from Postgres latest. And let's say for some reason I want to create different containers. This is a little bit of a funky example, since with Postgres we might not do this, but maybe what we're doing is, because we're not talking about databases here, we're talking about completely different containers. Docker container running a whole Postgres server in its own Linux environment. Oop. There we go. Let's try this again. And I could have another Docker container doing the same thing. And I could have yet another doing the same thing. And each one could be independently started and stopped. Start, stop, create DBs, put data in DBs, etc. And they're all independent. I could actually have as many Postgres servers as I wanted running on my computer. Now, why I would want a whole bunch of Postgres servers, I'm not so sure, but just because we kind of saw that from the example of the Dockerfile, I wanted to run with what we saw. And this could be anything. So, you know, let's say instead of Postgres, this is Nginx. Or let's say for some reason you wanted to have a whole separate Linux environment where you wanted to install a different version of Python or change stuff that would maybe break something else. Like you could do all that without actually messing up your own operating system. So it's actually really, really cool and incredibly powerful. Or, you know, let's say for some reason you wanted to have like 3 versions of your Django REST API. So we could have, yeah, the container runs the image. The terminology is definitely a little confusing. An image is like, you know, the mold, you can think about it, and then we stamp the mold to get the thing. And like Brian was saying, I think thinking about like OOP, and like I define a class, but I can create multiple instances of that class. And then like, you know, once I have like an instance of a car class, I can change stuff to that instance and it doesn't affect the other ones, is a good way to think about it. Except instead of like objects and instances, we're talking about like whole like operating systems and like tech stacks, like basically whole virtual machines, whole computers. And so you could imagine if, say, we were deploying onto the cloud and I had Django and Postgres and Nginx for my full stack set up for production, and I wanted to have the live application for my site that real users were using, and say I wanted to have like a test or a dev environment for my site that was live, but where it wasn't shared with the world, and where like the in progress code could be put as devs were working on it, and we could run, say, end-to-end tests against it and stuff like that. And maybe I have a staging environment that's sort of like stable and in between like dev and prod. And so we're Nordstrom's, and before we have a big change to the Nordstrom's e-commerce site, we put it on our staging environment so that the product managers and the business people can play with it and interact with it for a couple weeks, and it can be real. And then when everyone has given it the thumbs up, we deploy it on the prod. And I can have like completely separate environments for my whole system on the cloud. Okay. I've gone on for a bit and it's almost 11, so this is probably a good stopping point. Anything else on people's minds before we wrap, or folks that you have questions on or stuff to dig into? Okay, awesome. So tomorrow, to give just a very quick preview, what we are going to be looking at is we are going to be throwing Django into the mix with the Dockerfile, where the end goal here is, instead of going manually through all the steps that we saw for that AWS deployment lesson, we will end up building Docker files and Docker images to do that for us. That should help us actually let us test some of this locally. And then when we go on to AWS, we just need to run like Docker pull or Docker run, and we get our whole application configured and ready to go. Now, there's always going to be a couple wrinkles in that, but more or less, that's the goal that we're kind of working towards with this. So thank you folks very much. And we're just going to kind of dive into this and keep rolling with this tomorrow.